You know I've been taking some time and I've been keeping to myself. I had my
Good afternoon, ladies and gentlemen. Today is the day. It's Friday. Woohoo! Today is Friday. We pray everybody's safe out there driving. It's very slippery outside. We pray, everybody recover from this COVID-19. It's a lot of depression, anxiety going on. We make sure, I know the government is making sure people are safe. So today we talk about physics. And because one thing about the AT podcast, it's about educational, we're about mentoring, we're about everything you think of. We discuss everything, so it's not controversial. So today I have Mr. William with me, and he's a science teacher, and he's gonna talk about physics. So Mr. William, I have a question for you.
Yeah.
We're talking about the string theory today. So what is a string theory?
So string theory is, to start off, we all know that everything's made up of atoms. Now, the atoms are then made up of protons, neutrons, and electrons. And the protons and neutrons are even made up of smaller particles. So what we have is the base particles of leptons and quarks. Now, for string theory, the theory is that each of these smaller particles are made up of vibrating string. And that's the smallest base form of string, of what everything is this string. And that's the gist of string theory.
Yeah, when I was in school way back, like 97, and something like that, and we did something like that in chemistry too, with the atoms and the periodic tables and all that kind of stuff. So I have another question for you about the string theory. What is the M theory?
So string theory actually has a whole bunch of different branches. There was a whole bunch of different theories about string theory. There's some stuff that wouldn't make sense mathematically. What they ended up coming up with is that each of these theories about string theories were all not incorrect, but correct. So they unified them, and that's what M theory is bringing in all these different theories about string theory. And it makes it that one unifying act.
That's wonderful. I hope you guys are having information about physics. We're talking about string theory. There's different sections of it. So that's our discussion today. And I have another question for Mr. William. Mr. William, how many dimensions are there on this?
That's a very good question. We can see 3 dimensions, right? So as you can tell, we can see 3 dimensions. We don't look at it 2D. Now the 4th dimension is time. So we can tell when time's going forward, and then as well, it gives us that sense. But here's the thing is that according to string theory and M theory, there are actually 11 dimensions. So these dimensions get to the point where as you go further up in the dimensions, then time and place kind of mix and mingle. So even though we might be here in this instance, doesn't mean that in another, if we were able to travel through dimensions, we would be at a different time. And time is just a concept in our brain, and that's just one of the dimensions that we can see. But there are other dimensions that are possible, and that's one of the things as well. Some scientists believe that we have visitation by aliens and different things like that, and it's because they're able to travel through these other dimensions.
Wow.
It's kind of like if you see a ant on a power line. When we see it, since we're further away, it looks like it's just a 2-dimension. Just you have the X and Y axis, and then you have the ant running across. But for the ant, they would see it as more of a 3-dimensional area.
Oh, that's great. That's good information. We're talking about science. We're talking about physics. We hope this is a good education for people who listen to this podcast, the AT podcast. I have a last question for you, Mr. William. And my last question on this string theory is, what is the Heisenberg uncertainty principles? I want you to elaborate on this one.
Okay, so the Heisenberg uncertainty principle is the concept that if we were able to tell the position of something, we cannot tell their exact momentum. Now, what they've done is if they've done a test that's called a dual slit experiment, where they had two slits and they fired photons through the slits. They were able to see that they made basically a wave pattern. So it makes it seem like a photon is traveling in the form of a wave. However, when they put a camera close to the two slits in order to observe it, the wave then became just a random mesh of particles. And the whole thing is that for the Heisenberg uncertainty principle, when we start looking at things that are on the quantum level, so the smallest possible level, that it starts to break down if you know the position of the particle. You can't tell the exact speed of it, the exact momentum. If you know the momentum, you don't know the exact position. That's where you get events like quantum tunneling, which is a phenomenon that things that doesn't happen that shouldn't happen does happen. And that is something that's observed when it comes to, and we can see this in the Higgs boson, the Hadron Collider as well.
So this is the information today we have for you for physics on the string theory. I hope you educate yourself. I hope you do your research. I hope you learn something from this. I want to take this opportunity to say thank you to Mr. William for this information and your science knowledge that you give out to the people. Education is key. That's one thing people will never take away from you. It's your education. Think. It's not hard. It's something you can do for yourself. It's not hard to be thinking. So thank you, ladies and gentlemen. From the world of the AT podcast, have a good weekend.
See you.